Previous problem. A book of mass m is held between two hands. Held between two hands by applying equal horizontal forces. The coefficient of friction between the surfaces in contact if the book is in equilibrium. Right. So, what they're saying here, a book so just imagine now this book we have pressing like okay. So equal force we apply. Yeah, equal force we apply. Equal amount of force is applied like this. So this force which will be a F and this force is a F only. Both forces are equal. Now this mass of this book which will be a M. So you can see now. Then what are the forces acting on this now here? So first the weight of this book which is downward direction will try to fall. Right. Now where we have a normal reaction. Yes, normal reaction. Here we have a normal reaction. Wherever the contact between the two bodies are there, hands and the book, there we have a normal reactions. And here also normal reaction. No, it will be always perpendicular to the contact body. So if we have placed the body like this, so here the which force makes the body to fall, not to fall? Yes, this one. Yes, that is a normal reaction. Now here if you are pressing this one here, and there is a normal reaction now here. In this case, this direction. Okay, so normal reaction doesn't mean always upward direction or downward direction. So it is always perpendicular to the contact between the two bodies. Right. Next. Yeah, you tell me now which direction the book can try to fall. Ah, which direction the it will tends to fall? Downward direction. So friction is what direction? Upward direction. Friction will opposes the motion. And friction is which direction? Upward direction. So friction is always between the two contact bodies. Wherever the if the contact is there, we have friction is there. Here we have this a contact between the hands and the book na. So that's why here we have a friction is there. And here also contact between the book and the hands. If there is a contact is there, then frictional force is there. Whenever there is a contact is there, then we have a friction is there. Yeah, now you tell me now in this case. Now, so you tell me now here, this block, so cannot move right side and left side. That means this normal reaction will balanced by this force now F. So that means how much the normal reaction tell me now, which is equal to F. Right. Normal reaction equal to F. Then how much the frictional force you tell me now? Frictional force which will be equal to mu into N, and that is equal to what, tell me now? Mu into F. How much you tell me now? Mu into F na? Now, so you tell me now here, the body is in equilibrium, should not move up or down. That means what I mean, upward force has to balance it by the downward force. How much the upward force we have? See that one. How many F's are there? So here there's a friction is there. Here also contact is there. Now friction is there. So equal friction. So that is how much the upward force you tell me now. That is 2F, which is equal to what you tell me now, mg. So that means, so that is 2 into F is equal to what we can say, tell me now, mu into F, and which is equal to mg, right? So from this we need to get the coefficient of friction. So that is how much, you tell me now? Mg by 2F. Okay. Next. A block of mass m is placed on a surface having vertical cross section y is equal to x square by 4. And if the coefficient of friction is 0.5, the maximum height above the ground at which block will be placed without slipping. Right. So here, look at now what they're saying here. Understanding the problem is important here. So first of all, they given the equation given. What is that equation? Tell me now. Yes, y is equal to x square by 4. So do remember, if the power of x or y is more than 1, then that is a non-linear graph. Yes, when we have, so whenever we have y is equal to something k into x, we write x power 1, y power 1, that is a linear graph. If it is more than 1, then that is a non-linear graph. If the power is more than 1, then that is what type of graph is a non-linear graph will come. Right. If it is more than 1, then it will be a non-linear graph will come. Right. So you can see now here in this case power of x is 2 na. Power of x is 2. That means what I can say is a linear or non-linear? Non-linear. If the power is 2, then that is called as a parabola. It is a parabola. So this means, right. So if I say this is my x-axis, this is my y-axis. Here. And which has a square? You tell me now. X has a square, y has a square. X has a square, that means it is symmetrical about the y-axis. If the square is for x-axis, symmetrical about y-axis. So symmetrical means what? So left side, right side is same nature. So this graph, which will be like this. This point you understood now, first of all. Let's say parabola, that is equation is given as y is equal to x square by 4. Y is equal to x square by 4. Here, a block, the thing is here, this graph is given to understand this thing here. Y is given as, what, tell me now, x square by 4 given na? Y is given as x square by 4. So you tell me now, I can take different values for x, I will take. Let us take now when x value 0. How much the y value? 0. So when I take this as, so x is equal to 1 I have taken. Then y value how much, you tell me now? 1 by 4. I have taken x is equal to minus 1. Then y value how much now? Plus 1 by 4 minus 1 by 4. So that means when x is equal to 2, y value how much now? Yes, so that is how much now? 2 square means 1 plus 1. When x is equal to minus 2, then y value how much now? 1 only. So locate the coordinates now here. This coordinate 0 comma 0. Mean this coordinate is 1 comma 1 by 4 now. These coordinates are minus 1 comma 1 by 4. And this is 2 comma 1. This is minus 2 comma 1 now. These are the coordinates coming like this. Locate the points now here. 0, comma 0 means here. Next we have 1, comma 1 by 4. X value 1, Y value 1 by 4 here. Then minus 1, comma 1 by 4 means where? So here this thing exactly opposite now. 2, comma 1 means somewhere maybe here. Yes, minus 2, comma 1 here like this. By joining all these things, we'll get the shape like this now. That's right. So we got this graph now here. Now look at now here. See this thing here. Y is equal to x square by 4. So here a block. So this is what a block of mass m is placed on surface having a vertical cross section like this. A block is placed like this. Imagine. A block is placed like this. That's what they are saying here. The maximum height where I need to place. Either I need to place here, 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 such that the block without slipping. That's what they ask you, na? Yeah, that means what tell me now here? When the block try to slide down, so that it will be friction will tries to oppose. So the frictional force and the sliding the force now will balance. The body is at rest only, na? So that location they ask you. Right. Now let us say here is a block now here at this location the body is at rest. Now you tell me now what we can do here. So at this point what I am doing now here. So I am drawing a one tangent I am drawing here at this location. Tangent I am drawing here. I am drawing a one tangent. Okay. So this tangent I have drawn now this angle. This angle we are calling this as a theta. Tangent I have drawn that is nothing but what tell me now theta. Right. Now you can see now here. So look at now here. What are the forces acting on the block? You tell me now here. So this mg downward direction here. And here what I should do. This is also like an inclined plane only na. This is the angle. Angle of inclined plane is theta now. Now here we should draw a normal. Remember. So this is the normal. So this is n. And this direction, how much the force you tell me now? Yes, this is mg cos theta. Okay, now this direction, how much is force you tell me now? Yes, along this direction. This is how much you tell me now? mg sin theta. Okay, now because of this mg sin theta, block will try to slide down because of this thing. But there is a opposing force is there now. What is that? Frictional force. Okay, now you tell me now here in this case. Now you tell me now, first of all, how much the normal reaction tell me now? So the normal reaction, how much you tell me now? mg cos theta. Then how much the frictional force? How much the frictional force you tell me? F is equal to mu n. And how much the frictional force you tell me now? F is equal to mu into n. N is how much now? mg cos theta. This is mg cos theta. Frictional force we have. Next. Now look at now what they're saying here. The block should not slip. That means what tell me now here? Because of which force the block will slide down. mg sin theta makes the body to move down. But the body should not move now. That means upward force balanced by downward force. Then the body at rest only na? Yes, so that means what indirectly what we can say frictional force must be more. If F is more, upward force is more compared to downward force, the body at rest only na? So that means what we can say now F must be greater than or equal to what I can say now mg sine theta. This point you understood now? The frictional force is greater than, then it is at rest only. So now you can tell me now we got this frictional force. How much we have? That is mu mg cos theta. Yes, this must be greater than what? Tell me now. Mg sin theta. So that means now will come get cancelled now. Right. So that is mu cos theta. That must be greater than what? Tell me now. Sin theta. Right. So from this, what we can say now, mu must be greater than what? Tell me now, tan theta na. Right. So from this, what I can say now, from this tan theta, I can write tan theta must be less than or equal to mu, I can say now. Now, so from this, so what is the minimum value of theta you can see now? So this is tan theta, this value, this maximum value of tan theta, which will be equal to mu only now. So we got this mu value. So how much now? So mu value given the problem, how much this value? 1 by 2 given na? Right. So tan theta is equal to 1 by 2. Now what I need to get now here? Y value we need to get. So for this, what I can do here? Tell me now here. Tan theta. So we have drawn a tangent. Tan theta is nothing but slope of a line. For the slope of a line, if the given equation, how will you get the slope now? Slope is nothing but tan theta only. Yes or no? Slope is tan theta. That's what we did now. This is tangent angle only now. So from this, we have the equation. Y is equal to what they given now? X square by 4 given now. Now slope of this line. Slope is what? Tell me now here. Slope means that is a tan theta. And that is also equal to what you tell me now, dy by dx na, remember. So slope is nothing but y2 minus y1 by x2 minus x1. That is nothing but derivative only na. Right. Now from this, we will get the dy by dx now here from this equation. Dy by dx, which is equal to what? Tell me now, 2x by 4. So how much the slope I can say now here? X by 2. So that is nothing but tan theta only na. Yes, that is nothing but what are x by 2. We have the tan theta we got from this equation. So this is, let us call this is one equation. Tan theta we got 1 by 2 na. I can place this value here. So from this x value, how much now? X value 1, then we'll get the y value. Yes, y is given as what? Tell me now, x squared by 4. That means y value, how much will come? Tell me now. 1 by 4. So height means y coordinate only na. So that means this one, when the block is at a height of how much this height you tell me now? This is 1 by 4. Then the block should not fall down. This height is 1 by 4. Right. Then next one. Next one. A block of mass m is pushed just enough to start it. That means I have pushed the block with certain force. It just its motion will start. If mu s and mu k are the coefficient of static and kinetic frictions, and the force continue to act, find the acceleration of the block. You tell me now. Initially, the body is at rest. Now, so for this body to start the motion, how much of force I need to apply? Yes, I need to apply certain amount of force we need to apply. What's the minimum, what is the force I need to apply so that this body will start the motion? More than frictional force. What type of friction this body will contain when it is at rest? So that means initially it has a maximum friction, that is called it as the limiting friction. If you apply a force that is more than the limiting friction, then only body start its motion, isn't it? If you apply a force more than the limiting friction, then only body will start the motion. Once the body started the motion, what type of friction now? Kinetic friction. So here they are asking, see that one, how much the force is applied is pushed just enough to start the motion. Yes, that means how much the force they applied is a that force equal to the limiting frictional force they applied initially. Okay. So indirectly they given this as block, a block of mass m. It started to start the motion. How much the force we need to apply? You tell me now here. To start the motion, we need to apply the limiting friction force we need to apply. This much force we need to apply. How much that force you tell me now? That is mu s into n. This much of force they applied. Then only body start the motion. And they given that, so then, so this is the force is continue to act, same amount of this much of force is continuing continuously. Once the body started the motion, what type of friction it will be convert? Then it has what type of friction? Kinetic friction. Now this has what type of friction is a kinetic friction. Then this, yes, FL is obviously greater than FK na. So that's why the body will move, isn't it? So now they ask him to find the what will be the acceleration. So that is what you tell me now. This is FL minus FK by mass, which is equal to here N is equal to mg only na. So we'll commit as what you tell me now, mu s into mg minus mu k into mg by m. Right. So here the n is equal to mg only, right? So from this, how much is acceleration you tell me now here? That is mu s minus mu k into g. With this much of acceleration, the body is moving. Understood the problem? Once again, read this one. Right? Then Yeah, try the next one. See this one. Read the problem. Try to understand. Read the problem. An insect can travel in a hemispherical ball of radius smaller. If mu is a coefficient of friction between the ball and the insect, hemispherical ball, that is ball. Okay, find the maximum height that it can travel in the ball without slipping. So, what, yeah? So like this, the so many things will come. You need to understand. So what they're saying here, a hemispherical bowl, a hemispherical bowl, hemisphere. This is the hemispherical bowl, right? So this is the center. Now here, this is the radius of the hemisphere. Radius is given as smaller. Okay. What they're saying here? Now, so an insect, so which is here, and this will try to move upward directions, right? Then after moving some height, it is falling. It is moving up, moving, falling. Yes. Now it is again, it is trying now here, trying here, falling. You tell me now here, why it will be fall? What is the reason? What is the reason? So because of its weight, because of its own weight, it will fall down, isn't it? And so you tell me now here, and so this one at this location, now here at this location, why it is not falling? Here, why it is not falling? That means balancing. That means what happens now? At this location, friction force is balancing. Friction is supporting, isn't it? And we are walking on the road. So why? What is the reason for walking on the road now? The friction is an advantage or disadvantage? Yes, friction has both. Advantage is a disadvantage there. You know, if we have a friction, we don't have any studies also. If the friction is not at all present, there is no studies also. So we cannot hold the pen also. To hold the pen, friction is required. To hold the book, friction is required. Then we don't have anything. So we no need to study. And even we cannot eat also. So if we want to eat something, friction is required. Ah, fri- ah, ah, then everywhere the problem is like that. So you might be seeing even if you pour the tea, so it will be float like this because of if there is no friction at all, isn't it? So look at now here. So at this location, let us assume that the insect can able to travel up to here. Beyond that, when it is trying to move up, it is falling because of the weight. Because of the weight, friction will support. Okay. Now let us say here, this much of height has been traveled. Okay. So here, this is what is the center point now. And here we have insect is there. So this is what you tell me now, radius only. So center to surface is a radius. Now here from here to here, this is I'm calling it as a this much of height the insect has traveled. So then we need to find that height only we need to find. Okay. Now look at now at this location. So at this location here, look at now, this is the normal now, tell me now. This is normal, isn't it? So this is the normal reaction is like this. Yes, the normal insect will push us, will cause certain force on this one. At the same time, this is the bowl also will offer certain amount of normal force here, this direction. Can you tell me now how much this weight we can resolve it now? So here, look at now here. If we call this angle, if I call this as a theta, here this angle which is theta. Now you tell me now here, this weight of this body which is vertically downward direction only now. How much this weight you tell me now? mg. Now look at now here, this is weight is along y direction. This is also y axis only now. So this angle is theta. That means this angle is also theta only. This angle theta. So this means this is extension now. This line and this line same only now. So that's why this angle same. So this angle is theta, right? Now what is this component you tell me now? mg cos theta. And what is the other component of this direction? Tangential to the bowl. So this is mg sin theta. This the insect is falling because of mg sin theta only. Since it is falling down, so that means here downward the frictional force is opposite direction na? So the friction is like this. Okay. mg sin theta, because of mg sin theta moving down, but friction will opposes the motion of the body. Right. Right. Now tell me now here, and how much the normal reaction? How much the normal reaction? How much the normal reaction? Normal reaction n is equal to what we can say now? mg. N is upward direction na? Normal. So this is a radius. mg cos theta. Normal reaction mg cos theta. So the frictional force is how much you tell me now? That is mu into n, and which is equal to mu mg cos theta. So this is the frictional force. Now, so the condition is what you tell me now here, the insect should not fall down. That means what should be now here? Frictional force must be greater than. So, which force makes the body to move down? Insect will move down. mg sin theta. That means frictional force must be greater than mg sin theta. So this F is how much now? Tell me now. Mu mg cos theta. That must be greater than what? Tell me now. mg sin theta. So that is, we can say mu must be greater than what? Tell me now. Tan theta. Mu must be greater than tan theta. So that means tan theta is less than mu na. So that means tan theta is less than or equal to mu. So this maximum value of the tan theta we can write it as what? Tell me now, mu only na? Right, maximum value. Now you see this thing. Now I need to get the tan theta from the triangle. So here, from here to here, this is how much now? Radius. This is what tell me now? R na. And this is also R only, isn't it? Now tell me now this part. This part is how much now? R minus H. Yes, now from this is, now this angle is theta. Now, so now this is, I need to get tan theta. Tan theta will come it as what? Tell me now here. This we don't know now. Yes, now here this value we should apply the Pythagoras theorem and we'll simplify now here. How much this value, if I call this is something x, get the x value. How much this x value now here? That is square root of what? Tell me now. That is r square minus r minus h whole square. Simplify how much this x value? So how much this x value will come here? Yes, r square minus r square minus h square plus 2rh ra. So this r square will get cancelled. So how much this x value will come here? That is square root of 2rh. How much will come x value? Square root of 2rh minus h square. We'll keep like this, we'll simplify. From this tan theta will come now. Now from this tan theta will come it as what you tell me now here? Opposite x by h na? X by r minus h, isn't it? X by r minus h, isn't it? So, and that is equal to mu only. X value how much? Yes, that is equal to mu only. Okay. Now from this, we need to get the value of h value, we need to get from this one. X value how much now here? That is square root of. X value how much? Square root of 2rh minus h square by r minus h equal to mu na. Now, we need to get the value of h value, we need to get from this. Cross multiply. Squaring on both sides better. Yeah, that is 2rh minus h square equal to what? Tell me now, mu square into r minus h whole square na. Squaring on both sides na. So that is 2rh minus h square, which is equal to again mu square into this is r square plus h square minus 2rh na. Mu h value we need to get. All h's are one side, remaining terms are other side. That is 2rh minus h square. If I bring to this side, this is mu square h square minus 2rh equal to what? Tell me now, mu square into r square. I'm getting very lengthy. Plus. Here also mu square is there, na? Coefficient. And this is mu square 2rh. Yeah, why this much of lengthy we got now? So this thing, mm, the value R, mm, this value theta, this value also theta. So we got this tan theta is equal to mu only. Mm. Yes, now if the values are given, then solving it is easy. Otherwise, it will be get very difficult now solving this thing. So this is now, yes, now here we'll do that one here. H square in these two common. Here also 2RH common here. Then we'll come it as what are 2RH we have taken common. Then will come 1 plus mu square na. Yes, here uh, minus h square we have taken common, then it is 1 plus mu square, which is equal to mu square into r square. Yes, now we'll take it as 1 plus mu square common now. Then it will become 2rh minus h square equal to what, tell me now, mu square r square. That is 2rh minus h square, which is equal to mu square r square by 1 plus mu square. Then we'll get the h value. Hmm. Right. Next one, take this one. Take this one. Sand is piled up on the ground in the form of a regular cone having fixed base radius capital R. If m mu, not m, this is mu. If mu is a coefficient of friction between the layers, sand layers, find the volume of the sand that can be piled up without slipping the sand particles. Right now, so just imagine now here, and what they're saying here in this case. So the sand they are placing in the form of cone, in the form of a cone, right? Mu is a coefficient of friction between the sand layers. Find the volume we need to find. So let us consider, yeah, this C is the cone we have formed like this. right, in this manner. Just imagine now here. So this is we have the cone like this, and this having some radius is given. So radius they given as what I mean of capital R. Next. Now, so as we know here, if we are placing the sand one over other, so that means we'll get to certain height. After certain height, what happen now? So it will fall down. Yes, why? Because the weight will increases now. Gravity increases, it will fall down. So we can able to maintain certain height only. We can able to maintain. After that, even still, if we place, it will fall down. So that's what they are saying here. And use a coefficient of friction between the sand layers. Find the volume of the sand. Let us say here, this height of this cone, which is equal to something h. Now we need to see here how much the height I need to place now. They ask him to find the volume of the cone. What is the volume of a cone formula? Yes, that is 1 by 3 pi r square h. No, now this formula. Volume of the cone. So we know this r value, pi value constant, fine. H value we don't know. H value we need to get here. H value we need to get. If we know the H value we'll put here, we can get the volume. Right. Now, let's consider, yes, this is the height of the cone. Right. So let us consider here, I have taken some particle we have taken here. So this particle, if we have taken, now let us see what are the forces acting on the particle at this location. We have taken some particle we have taken. We need to see this thing here. What are the forces acting on the particle? We'll see. Right. Look at now, first of all, weight. So we draw a normal, we draw first. And this is the normal. This is N. Next. So we need to resolve into components now here. This weight of this particle. So this direction. What we have tell me now here? This is, now this is weight of this particle is vertically downward direction like this now. And that particle, so this mass is m, this is mg. Now if I say this angle is theta, then this angle is also theta only. Now tell me, vertical angle. Now you tell me now this components now here, and this component of weight, how much this component of weight, you tell me now, this is mg cos theta, isn't it? And this component is what, tell me now, mg sin theta. Till here fine na? Now tell me now, what is the normal reaction here? Yes, what is the normal reaction in this case? You tell me now. How much the normal reaction? So which is equal to mg sin theta, normal reaction. So how much the frictional force, you tell me? Frictional force is mu into n. So that means frictional force is what, you tell me now? Mu mg into sin theta. Now because of mg cos theta, the sand particle which is here will try to fall down. So then frictional force will opposes this motion now. Now, so they are saying here, now, so for the sand particle should not fall down. The condition is what, tell me now? Frictional force has to balance it by the mg cos theta, isn't it? So because of mg cos theta, it will try to fall down. Then, so if the friction will oppose us to fall. If the friction is more, then it will be does not fall now. So for that, what should be now for equilibrium? We can say that F must be equal to what we can say now? Mg cos theta, isn't it? We already know the frictional force how much? Frictional force is mu mg sine theta, and which is equal to what, tell me now? Mg cos theta. From this mg will get cancelled. So we'll come it as what, tell me now? Mu is equal to what, tell me now? Cot theta. Mu is equal to what, tell me? Cot theta. Cos by sine na? Right. Now you can see now this is a cone. Base of the cone they given as how much, you tell me now? Base is r, this height of the cone is h. Now this angle is theta only na? From the triangle, can you tell me now cot theta value? Yes, cot theta, which is equal to h by r. From this, h is equal to what I can say? Mu into r. H we got it as mu into r. Yeah, we'll put in the volume. Then, so volume of the cone, how much you tell me now? So this volume V is equal to 1 by 3 pi r square into h. H means what, tell me now? Mu into r. So it will come to be a 1 by 3 pi r cube into mu. This is the volume. Understood this thing here? Everything, whatever we did, all these things to find the value of h value. How much the height we can able to maintain. Done? Completed now. Next one. Hanging chain. Quotient is mu na. So mu will take. Mu is a quotient of friction between the chain and the table. Then find the maximum length of the chain that can hang over the edge of the table without falling. So what they're saying here. So now how much the hanging part? So this length, so that it will be at rest only. Okay. So we have just imagine we have taken a belt we have taken now. So some part of belt is hanging, some part of belt is on the table. Now, so how much will be the hanging part of this belt, this length, so that it will be a rest maximum length we are talking here. How much now? So here initially we are putting some length. Now it is rest only. If I increase, now when I move down, so that at certain value it will be at rest. If I move little, then it will fall down now. So what will the maximum hanging length we need to find out? Understood? So that means that is simple. What we can say now here in this case, magging. So if I call, so mu is a coefficient of friction. mu is a coefficient of friction, which is equal to simply hanging mass. Hanging mass by resting mass. Hanging mass by resting mass. That means hanging part by resting mass means how much the mass is on the table. And the same thing we can extend to in terms of length. What we can write now here, hanging length by resting length. Hanging length by hanging length by resting length. Right? Now, if I call this as a hanging length, which will be equal to L1, so resting length is L2. So how much the coefficient of friction, you tell me now? The coefficient of friction mu, which is equal to hanging length is L1, resting length is how much? L2. This is the coefficient of friction. L1 is what, tell me? Hanging length. L2 is the resting. Resting length means the amount length lies on the table. That is a resting length. Yeah. And where this L1 plus L2 will use what element of total length? Total length of the chain. Total length is how much now? L1 plus L2. This is the total length of the chain. Okay. Hanging length by resting length. And if they given masses, hanging mass by resting mass. Right. Tell me now. A uniform chain of 6-meter length is placed on a table such that part of its length is hanging over the edge of the table. The system is at rest. The coefficient of static friction between the chain and the surface of the table is 0.5. The maximum length of the chain hanging from the table. Yes, so that means what they're saying here now, mu value given na, mu is equal to what the formula. So this means hanging length by resting length, isn't it? They given 6 meters is given. What is the 6 meters is total length of the chain. 6 meter chain length is given as 6 meters is given. So that is what I'll know, L1 plus L2 they given as a 6. Okay. So now, so this mu value, how much now? This is 1 by 2. So from this, we need L1 is the hanging length. L2 is a resting length. So that means L2 is equal to what from this now here? 6 minus L1. So that is L1 by 6 minus L1. Solve this one to get the L1. L1 is what? hanging length. L1 is the numerator is hanging length. That hanging length will get. So how much will come? So this is 6 minus L1 is equal to 2L1 na? So 3L1 is equal to 6. So L1 is equal to how much now? 2 meters. Right.